Hello YouTube, I am Arend Peter, and today I'd like to tell you how to implement Terraria-style terrain generation in GameMaker Studio. So, this should be a pretty cool tutorial. I think it's going to be pretty neat. For as far as what you need to know, I think it's going to be not too terribly complicated. We're going to use some loops, some fairly basic programming. We're going to do a little bit of math. But the main new thing is Perlin Noise. So we're going to be using the Perlin Noise Algorithm to do this terrain generation. And that might take some time to wrap your head around. So, but as long as you're ready to learn something new, to learn the cool Perlin Noise algorithm, this should be pretty fun. So with that, let's go ahead and check out what the final result is going to look like. Alrighty then, here is our final product. We have terrain. If I press space, it will regenerate. And the key thing about this, which makes it look natural yet random, is that we have you have a clear pattern. Like, it's not just randomly up and down, random value. Like, it's peculiarly going down and then up and whatnot, but you see little bits of noise added onto it. So that is the power of Perlin Noise. So yeah, this is what we'll be making today. So we're going to go ahead and start a new project. Make a new project, and let's just get the groundwork done. So we need to load in our sprites. I made two images. If you would like to use these same ones, you can go and download the source code from the description and pull it from there. Otherwise, you can make it yourself. They're just simple gradients. It doesn't really matter. Just threw something together real quick. So I have one image for the dirt, and I have one image for the grass. Alright. Now, we'll go ahead and create object for those guys real quick. Oh, dirt, and oh, grass, and grass. Alright, okay, now let's get in the generator. Generator. So this will generate our terrain. That doesn't need a sprite. And just to kind of get our hands dirty and to get a feel for what we're doing, we're just going to make a quick script to fill up the whole area with blocks, so we can feel comfortable with that. So I'm going to make a loop equals 0 I less than room width over block size. Let's see, so block size is going to be the width of our block's width / height. So right, it's 32, but rather than hard coding it, I'm just going to go ahead and pull it out. So I'm just going to say block size equals sprite get width s dirt. Okay, so that'll be our block size. So this first loop is going to, let me finish up real quick, I++. This first loop is going to go over our columns. So the number of columns is equal to the number of times our blocks can fit in width-wise. So that's what this whole calculation is for. The width divided by block size is how many columns we have. Okay, and then we'll make another loop for the inside to go over our rows, create each block in the column. And we'll have a similar calculation here, room height divided by block size. J++, and there we go. And that is our rows. Yeah, looking good so far. And then for each one, we're going to create a block. Let's create a dirt for now. For as far as the x and the y, we're going to calculate those. It's a function based off of I and j, so our x is going to be equal to the I times the block size. So, for all the on the left, we want our x to be 0. Our I is 0, block size is 0. And then for each one we go to the right, it's going to increase our block size. So if we go 1 to the right, we want it to be block size, and it's just a fairly simple function of I. I'm going to actually go ahead and bump that up here, so that way we're not recalculating every time. This for the y we need to calculate in here because it changes each time. So y equals, let's see, this is a little bit trickier. So I kind of want to start from the bottom. So when j is 0, I want it to be room height minus block size. Because remember, the y position is the top of the block, so we want the top of the block to be above the bottom of the room, so that's what this is for. And then for each successive j, we want to go up by another block size, so we're going to say minus j times block size. Okay. So that should work. X, Y, Y, and finish up our brackets. And this should go ahead and fill the room up with dirt blocks. Let's see. So I'm gonna make the room size 960 by 540, and because I don't like the gray background, I'm gonna make it a nice pinkish color, maybe sunset. A little darker. Something like that looks good. Yeah. Alright, and now if we throw our generator in the room and press play, we'll see what we get. Cool. Fills up the whole room. That's perfect. Just to show you guys something, I'm gonna show you guys what random noise would look like to show you how it's different from Perlin noise. So we're gonna set our we're gonna create a variable called max height. We'll set it equal to this guy, and then instead of going up until the blocks we can fit in, we'll go up to I random range 0 to max height. And I'm going to actually calculate this outside, I think. Alright. So this should basically give us a random height for each one, and you'll see that this doesn't look like terrain at all, if I did this correctly. Yeah, it doesn't look like terrain at all, just a bunch of random pillars. Alright, so instead of doing random range, we're going to do get Perlin noise. And it's going to take the same parameters, but it's going to give us, well, no, it's not going to take the same parameters. So, whereas random noise, with each individual column, they're all independent of one another, but for Perlin noise, we want it to be affected by the ones next to it. So, we can't just randomly ask for Perlin noise. We have to tell it for which column we want the noise. So, for the ith column, give me noise, and I want it to range from 0 to max height. That's how these parameters are going to work. Alright, and we're going to create this script, and we'll call it get Perlin noise. So if I check out of there, hit space over here, it should recognize it. Cool. Alright, so we're going to be spending most of our time in this little script right here. So we're going to take our parameters first. So our var, we'll call it xx, I guess, for which column. Is going to be equal to argument 0, and that's the first thing that's passed in. Our var range is going to be next thing, equals argument 1. Awesome. Alright, so now what I'm going to do next is going to be specific to the Perlin noise algorithm. So we're really going to need to understand a little bit, have a little bit of intuitive knowledge of how it works before we actually go ahead and write this thing out. So I'm going to pull up a website. I'm just going to go and look up Perlin noise. Perlin noise. And you see this purple link that I've clicked many times now is where we want to go. freespace.virgin.net, hugo.les models, m_Perlin noise. So this is a really good article telling you all the details about Perlin noise, what you can do with it and such. And I'll go and outline it for you. So this graph right here looks a little bit like what we did earlier, just pulling up random points for each column. So what they've added here is, for us, each point was a column, but in this scenario they're actually making each point maybe every 4 columns or something like that. So what they do is, once they find all the points, they fill in the spaces between the columns using an interpolation algorithm. So interpolation is just filling in the blanks. So here we see these 2 points. It corresponds to these 2 points, and they use, looks like some sort of sine curve or something like that is what they're using to fill in those points. So random points and filling in the blanks is a core thing that is one of the bases of the Perlin noise. So this is just some terminology. They call amplitude the range at which the points can be generated. So all the points are within this amplitude, and the wavelength is the distance between individual points. So if there's 4 columns between each of these points, that would be the wavelength. Okay, so now this chart right here is what we're going to be talking about a lot. So here we have one of those graphs which has a really high amplitude but low frequency. Low frequency means a higher wavelength. So you can see, if we look at this, we can kind of eyeball it and see there's 1, 2, 3, 4, 5 random points generated in here, and they're just interpolating between them. And we can kind of, so you can see high amplitude, there's big changes, but the changes don't happen very often. That's the characteristic of high amplitude, low frequency. Whereas if you go to the very end, you can see that's a very low amplitude and high frequency. So there's a ton of changes. If you look at these dots, you can see it goes up and down a lot. However, it doesn't go up by much because of the low amplitude. So we generate a bunch of these, and we start with a high amplitude, low frequency, and as we go, over time we increase the frequency, decrease the amplitude, and then you add these all together and you get something like this. And it has the characteristic of terrain that we want. It's not pure randomness. There's definitely a trend here, which more or less follows this guy, with the high amplitude, low frequency. However, if we look closely, there's also some more random stuff happening. It doesn't clearly follow a pattern if we look at it more closely. So this is what we want. So first off, we're going to generate something like this. That's what our goal is right now. So I'm going to call a variable chunk size, and this is going to correspond to our wavelength. I'm going to set equal to 16. Alright, so that's the first thing we want to do. Next thing we want to do is figure out chunk index, our chunk index. So these random points in here are all samples. So we might be, when we're generating Perlin noise, you might want to find out something right here. So our chunk index is going to be the sample to our left. So if we're right here, we would want the chunk index be 2. So that's the second sample number 2, because we have 0, 1, and 2. So the way we're going to calculate that is we're going to do xx div 16. So the div operator is integer divide. So if our xx is equal to 22, let's say, just for example, then if we just straight divided it by 16, that would be, oh boy, 1.375? But 1 point something if we straight divide it by 16. But div is saying we can only handle whole numbers, so we can fit 16 into there one whole time, so we're just going to say it's 16 because we can't handle decimals. So for 22, our chunk index would be 1. That's the correct answer. And then let's see, the next thing I want to do is, so we know which sample is next to us. Now we want to know how far away we are from that sample. So I want a number between 0 and 1. 1 being we're practically at the next sample, 0 being we're right on this chunk index sample. So I'm going to calculate that. We're going to call it prog. Our prog is our progress. And what I'm going to do is I'm going to do another piece of math. I'm going to do xx modulus, percent, chunk index, chunk size. And I did the same thing last time. I want this to be chunk size. I don't want to hard code in the value 16. Okay. So I need xx percent chunk size, which in this case that would be 6. 22. If we divide 22 by 16, 16 will go in there once, and after we divided, the remainder will be 6. There'll be 6 left over. So in here, this will give us the xx percent chunk size will give me what's left over after I divide chunk size out of xx, what the remainder will be. And I have a whole tutorial about modulus if you want to learn more about that stuff. So now I'm going to do normal divide, so there will be decimals by chunk size. So this, if you think about it, after dividing by chunk size, after finding the remainder can not be bigger than chunk size. It's between 0 and chunk size, if you think about it. Because if it's bigger than chunk size, that means that chunk size could have gone into there again, and that's a contradiction. So then by dividing by chunk size, we get a value between 0 and 1. Alright, awesome. Now the next part, we want to find random values for our samples. So I'm just going to left random equals something, and var right random equals something. So I want these to be just pure standard random numbers, but the key thing that I want to do here is this left random is going to be the random number that corresponds to my chunk index. And every time for this chunk index I want to have the same random number, so I'm going to create a special random function. I'll call it
I would call it random, but that's already built in function GameMaker, so I'm going to call it random seed. That was just the best thing I could think of. So the seed we want for this random number is chunk index. And also, we want to tell it the range that we want. So I want it to range between 0 and whatever this range is. And I want, every time I input chunk index in this range, I want to get the same random number from this thing. So that's for the left one, and now I do random seed. And this is for the right one, which would be the next sample, plus 1, and I do range. Okay. Now let's write this function. I'm going to take that away real quick. So we have create a script. I'm going to call it random seed. I'm going to take in arguments. So var xx equals argument 0 and var range equals argument 1. Boom. Okay. So I'm going to say I'm going to create a seed for our random number. We'll call it xx our seed. And then what I want to do is I want to add a big number to it. So 1, 2, 3, 1, 2, 3, 4, something like that, something in the million range or something along those lines. Because with most random number generators, generally the more the larger number you put in, the larger number you select for the seed, the longer it's going to take for it to start repeating itself. So we don't want it to repeat itself anytime soon. So we're going to use a large number for our seed. So I'm going to go and add a big number to this, because the number we're putting in here isn't going to be very big. So, and now we're going to create a random number. So what I want to basically do is I want to do rand equals I random range like we used earlier, and I want it to range between 0 and whatever our range is. But in order for it to give me the same random number every time I use this seed, I'm going to need to make sure that this is seeded at that value. So I'm going to say random set seed to be our seed. So since we're setting the seed right beforehand, and then we call random, this should give us the same thing every time when we have this seed. So that will make it reliable, make it work the way we want. So now I can go and return rand, and that's it. So this is our random seed function. If we give it the same seed, it'll give us the same random number. It'll spit out the same random number, which is very cool. Okay, we need to finish up this Perlin noise thing. So we have our left random, now we have our right random. So our value is going to be somewhere in between. So if our prog is 0.5, that means we want it to be 50% between linear and right. Or rather, we want to interpolate somehow between left and right. And the way it'll be something based off of prog. How close this left or right will be based off of prog. Alright, so there's a couple linear interpolation methods. This article, it outlines a few of them right here. We're going to be doing the simplest one, which is linear interpolation. In theory, if you try some of the other ones, it might look a little bit better, but linear interpolation is pretty simple, and I think it still looks pretty good. So, wrong script, over here. So here's the way you do linear interpolation. So our noise is going to be equal to 1 minus prog times left random plus prog times right random. And that's all there is to it. If we think about this for a second, when I defined prog, I said if it's 0, it's going to be right on the left value, right on chunk index. If it's 1, it's going to be pretty much at the next one, the next chunk index. So if our prog is 0, this will be 1 times left random and 0 times right random. So we end up getting just purely left random. And if prog is 1, it ends up being 0 times left random and 1 times right random, so we get right random out of it. And if it's somewhere in between, if it's 0.5, it'll end up averaging the two. So that's how linear interpolation works. And now we can go ahead and return noise. And that's pretty much all there is to it. One thing I'd like to point out before I start is that I made a point of generating this Perlin noise outside of this loop. When I originally wrote this, I inlined this, so I did it like that. And that's a problem because on every iteration of the loop, it reevaluates this, which is, I guess, okay. It comes out the same thing, but this Perlin noise can be a fairly processor-intensive operation. So we want to compute it we only want to compute it as often as we need to, and by pulling it out here, we're computing it less. All right, let's see what we got. It's not happy. Why is it not happy? Okay, so var is defining a new temporary variable, and I'm defining two temporary variables called the same thing is what it's saying. So by taking away that var, it should be happy again. My bad. Alright, cool. So I'd like to see some more out of this. Okay, so it works, but I'd like to see some more patterns. So the way I'm going to do that is, instead of setting the seed to be instead of adding this set value, I'm going to add oGenerator.seed. And in oGenerator, we're going to create a seed, and we're going to set it equal to random range, and I want it to be between 0 and we want the seed be between 1 million and 10 million. Just fairly large numbers, I guess. And we shouldn't make it a var, because we want this to be accessed at any point in the game, not just in the beginning. Even though, come to think of it, we might be able to get away with calling it var, but we shouldn't out of principle, because it's being accessed elsewhere, and we may need it later on. Okay. And additionally, I'm going to have something happen when I press space. I want the game to restart when I press space. Game restart. Cool. Now when I play it, we get something. Okay, that looks pretty good, I guess. Okay. Okay, this is a good one. I'll work out this one. Oh, so as you can see, when we press space, it regenerates. So you can clearly see we've picked 3 sample points. We have one down here, one up here, and one over here. And this is because we chose a chunk size of 16, and I believe there seem to be about roughly 32 fitting in here. And in between, it's just filling in the blanks. It's a straight line in between. So we go from here up to here, and just a straight line, and a straight line over here. So that's pretty much exactly what's happening in this scenario. We pick a few sample points, and it's filling in the blanks. They're using some sort of a better interpolation algorithm here, but it's essentially the same thing. So now what we want to do is in our Perlin Noise, we want to go through and generate all of these and add them as we go to get something like this. And you'll see that's actually not going to require a lot of extra work on our part. So let's see, first off, we're going to want to create our noise earlier, so I'm going to create my noise variable up here, call it var noise equals 0, and then instead of setting it here, I'm going to add it. So that's one thing. I'm going to create a loop here. I'm going to do while chunk size is greater than 0. Jump over here, and I'm going to go ahead and select everything, hit tab to pull it all out. And then at the end of each loop, to ensure that it terminates, we're going to do 2 things. Number 1, we're going to divide chunk size by 2. And I'm actually going to do it a little bit this way. Chunk size div 2. Okay. I could do normal divide. That would work, except for I made my terminating factor greater than 0. So the key here is that when this is 1 div 2, the div will give me a 0, whereas the standard divide will give me a 0.5. So if I didn't do div, this would never terminate. It'll just go to 0.5, 0.25, whatnot. Whereas with div, it'll go to 0 right here, and they'll terminate the loop. So that's that. So remember, chunk size is basically our wavelength. So as wavelength decreases, frequency increases. So that term basically accounts for this frequency increase. And the other thing we will need to do is we want to do range divide by equals 2. Doesn't matter if we do div or divide in this one. And let's see. So that accounts for amplitude. We're dividing amplitude by 2 each time. All right. In this case, I think our chunk size is, well, okay. I don't think we'll hit this problem in this scenario, but I've ran this before, and I've come across an issue where range can equal 0 somehow. Or it could be less than 1, and that messes with. Actually, no, I lied. I'm gonna do range div 2. I think that will. I don't think the other one will cause problems, but I know this one won't cause problems. So if this at some point equals 0, then that messes with our random seed calculation, because we're doing we're doing percent range. Oh, well, maybe not. Okay, because we're doing 0 to 0 here, which the way I used to do it without cause errors, but I don't know if it'll cause errors in here. But just to be safe, I guess I'm gonna set a floor on range to be 1. So the way this works, we're choosing the bigger value, either 1 or range. If range is less than 1, this will set range to 1, and if range is bigger than 1, it'll remain unaffected. Okay, and I believe this is a completed Perlin Noise algorithm, because as we loop through, we are generating each of these various types, and we're adding as we go, so we should get something like this. Fingers crossed. Oh, silly. What did I do wrong? Okay, I'm just talking about chunk size being greater than 0, but I defined chunk size within the loop, so we gotta pull that guy out. Whoops. Alright, let's see if it gives us an error this time. No, it doesn't, but we do have some weird things happening now. I meant to account for this ahead of time, but I forgot. Oh well, I can explain it now. So what's happening is we're given a range, right? Which is how tall they can be. Which earlier it was staying nicely within that range, but as you can see right now, it's going way out of bounds. And that's because on this first iteration, this noise calculation, at most it can be equal to range, which we'll say 24 or something like that. At most. Okay. On the next one, when it adds on, at most it could be 8, because we're halving our potential range each time. And then it most could be 4. So the maximum height is no longer 24, it's 24 plus 8 plus 4 plus, yeah, and it goes on. So what we're going to do is up here we're going to add another divide by 2 range div 2. So this will actually fix it. This will ensure that by dividing range by 2 up here, it'll actually ensure that it'll never go above range, our original range. And it's actually kind of neat, because even though we keep adding stuff on it, and this loop could potentially go on for forever, we know we'll never cross it. And this is because if you take calculus, you'll know this is a convergent series. You can actually express it as a geometric series, and you can show that it will not go above range. But that's probably more than most of you wanted to know, but I think it's kind of neat. So now we'll play again, and now it should be neatly confined within our window. And it is. And this is actually the finished product. So that's all there is to it. So you can see it follows, you can see a general pattern, but there's also randomness to it. There's also like random things that are less predictable. Just to, put the cherry on top, if you will, let's add this grass in. So here, rather than creating dirt each time, we're going to create a quick if statement. So I'm going to say var block. Well, I'll create the block variable up here, and I'll say if we're at the top, if j is equal to h minus 1, if we're at the highest we can be, our block is going to be grass. Else, our block is going to be dirt. And in here, instead of creating dirt, we're going to be creating our block. That's all we need to do for that. Now we should get very pretty terrain, terraria style terrain, with our awesome Perlin Noise algorithm. GameMaker is crashing. It does this every now and then. I have faith in it though. I'm sure it'll come back. Yes, you've come back. Good job. So I've made this. Let's see, I've written it twice in Unity now, and I've written it once in GameMaker, and I haven't messed this up yet. I've gotten the grass part to work, the icing on top, I've gotten it to work every time. So what did I do wrong this time? I broke my streak. If j equals h minus 1, it's very odd. J equals h minus 1. Okay. J starts at 0, j keeps going once less than h. J is increased every time, so at h minus 1. Oh, okay, I think I know what it is. So this is saying j equals h, and if it's equal to h, that's 1, and this minus 1, so that's order of operations issue. I want to calculate that one first. No, that's not it. Okay. Well, I was almost afraid we were going to make it through this whole thing without doing any major debugging, but it worked. But that's not the case. I guess while we're here, another thing I forgot to mention is that if we play the game, well, I guess there's two things that little quick things I want to change. See how that looks? If I close out and play it again, it'll look exactly the same, and that's because even though these numbers are random, the seed that's being chosen is random. It's pulling the same seed every time. So to make sure that it's not pulling in the same random number each time, I'm going to add randomize up there. That'll fix that issue now. It'll show up differently. And the other thing, if I press space for a little while, I think I missed one. There's a certain thing that I don't want to happen. If I can see it. Okay, here it is. So I don't want it to do this deal. I don't want it to have no ground under there, because then you fall into the void, and that's not fun. So to avoid that, I'm going to do 1 plus max height minus 1 over here. So the noise is going to, its range has been decreased by 1, but it's also been pushed up by 1. So right now, instead of ranging 0 and max height, it's actually ranging 1 and max height. That's what we're doing here. Okay, so that's fixed that. We fixed that. Okay, now onto this, which still sort of baffles me. Okay. H minus 1 is indeed the highest number J can be. Yes, I agree. That should be the case. And Y is indeed at its lowest, meaning geographically highest, when J is at its highest. Yes, I agree with that. Alright, we're going to do some debugging. So I'm going to do show debug message. I'm going to do, just tell me I. I'm going to tell me H, I guess. Or we'll do string I plus string H. Okay. By the way, for debugging, I find this very annoying. GameMaker makes you put strings in there to convert the numbers to strings if you're mixing numbers and strings in here, and it's really annoying. And I actually made a tutorial a little while back on how to avoid this. So, if you are too sick of typing in string every time, you can watch that tutorial and check that out. So that's in the description. Okay, but yeah, that's a side note. I need to figure out what's wrong here. And then on each iteration over here, I'm going to do show debug message J. Alright, so if we look in our what are you doing? If you look in our console over here, it says, okay, I see what it is. It said, okay, 29 is the highest. Sorry, 29 is our index. The highest value is 10.31, and it goes to 10, which also doesn't make sense. Okay, so the reason why it's not working is I'm with this calculation, I'm assuming that H is an integer, which it's not. So to ensure that it is, I'm going to add around here, and that will fix all of my problems. Yep. Okay, that did it. Okay, that was a little bit interesting, but it doesn't matter. If you just keep working on it, edit, and printing stuff out, you'll find it. Alright, so that is all for this tutorial. Thank you guys so very much for watching. This is not all for as far as Perlin Noise tutorials go. I am making many more. I have a total of 6 Perlin Noise tutorials planned. If you're interested in learning how to do this in Unity, then you can check that out. It should already be uploaded. In Unity, I'll also show you how to do it in Minecraft, or how to make Minecraft style train generation. And there will be more for GameMaker as well. GameMaker, my next one is going to be how to make top-down random train generation with Perlin Noise. So yeah, all kinds of cool stuff you can do with Perlin Noise, and I think you'll find them to be neat. So with that, I will be signing off for today. Thank you so much for watching, and I'll see you guys on another day, I guess.